In a world buzzing with breakthrough innovations, there emerges a topic that transcends the boundaries of technology and science. Happening quietly in the environment, there's something critical recently discovered and went unnoticed until now. Even more concerning is that it's paving the way for catastrophic consequences for humanity through a snowball effect. We'll see in this video why this thing is so critical and are there any options we have to counter this. I am Abhishek and welcome to Revolutionary Engineering. Heat waves, wildfires, floods, hurricanes, and melting of glaciers are increasing in scale, frequency, and intensity. Warming rate of the planet has been on a rise and will worsen with increasing greenhouse gases in the atmosphere. So before revealing what's so critical and went unnoticed, it's important to get the answer to one question. Can we actually keep the global temperature rise within 1.5 degrees Celsius? And why 1.5 and not any other number? We'll look at this in a minute. Though many governments are taking steps to mitigate climate change, with renewable sources of energy displacing fossil fuels at rates never seen before in some parts of the world. But the real question is again not whether the efforts are being made or not, but actually it's whether all our efforts combined would lead to keeping the global temperature rise below 1.5 degrees Celsius when compared to the pre-industrial levels. So climate scientists, based on research, chose this number more than a decade ago as a speed limit for rising global temperatures, beyond which some effects of climate change start to become irreversible. For instance, we may experience catastrophic sea level rise due to this increase in temperature, and it would devastate few of the small island nations. But there is not so good news. This 1.5 degrees Celsius seems to look unachievable. You can get a feel of it by looking at the average global temperatures that hit nearly 1.3 degrees Celsius above pre-industrial levels in 2022 and are expected to reach 1.4 degrees mark. At current trends, the world could surpass 1.5 degrees of warming much sooner than a decade. And with such a rate, climate models assessed by the Intergovernmental Panel on Climate Change or IPCC project a range of warming that is well above 2 degrees Celsius by the year 2100. And it's predicted that 2 degrees rise can cause devastation at scale. More than 70% of Earth's coastlines will see sea level rise greater than 20 centimeters, resulting in increased coastal flooding, beach erosion, increased salt concentrations in water supplies, and other long-term impacts on human and ecological systems. As per one estimate, the world would need to reduce carbon emissions by 8% each year between now and 2034 to stay below 1.5 degrees of warming. This is like stopping the production of cement in all countries of the world from now on. And even then, the chance to stay below 1.5 degrees would still be 50%. Now, many of you might be thinking, how will we ever know that we have reached or passed this critical mark? A key issue is that global temperatures do not increase smoothly, with ups and downs that can occur over weeks to years, owing to variation from natural effects, for instance, by El Nino or from gases due to volcanic activity. The Intergovernmental Panel on Climate Change uses 10 and 20-year rolling averages when it calculates Earth's surface temperature. And this is a big problem. Zeke Hosfather, a climate scientist at Berkeley Earth, a non-profit organization in California, says that we could effectively hit 1.5 degrees of warming each year for a whole decade before the long-term average passes that mark. And this can be due to natural effects, as I already pointed out earlier, making it extremely hard in determining when the global warming crossed 1.5 degrees mark. What I mean to say becomes clearer with this chart from Nature's journal showing global average temperature change on y-axis and the year on x-axis. For the year 2012, the global average temperature rise was determined based on the observations from 2003 up to 2022, and then taking the average. But following the same method, we failed to predict the average temperature rise for 2022 until we have the data for all the years up to 2032. Now, combining the observations for the past decade and projections for the next decade can help us get an idea of the average temperature rise for 2022. This way, policymakers can know when the world would reach 1.5 degrees Celsius mark. But still, it would just be an estimate. But are there really any solutions to limit this warming? Many of the researchers think that there's only one viable way to deal with this, and that is to overshoot the 1.5 degrees mark for a time and then bring down the temperatures in the latter half of the century by extracting carbon dioxide from the atmosphere. Technologies that are primarily in focus right now are nature-based activities such as planting forests, subtly altering ocean chemistry to promote carbon uptake, capturing and burying emissions for power plants and steel mills, and extracting CO2 directly from the atmosphere. But none of these technologies have demonstrated the scalability that is the need of the hour, and there are problems with scalability too for few solutions. For instance, unnatural tree plantation without considering the biodiversity can ultimately harm it. Other technologies that can remove carbon at scale are either highly capital intensive or they are operationally expensive. For example, a common target for carbon removal technologies is $100 per ton to extract CO2 from the atmosphere. With such cost, we would need $22 trillion to sequester enough carbon to reduce global temperatures by just 0.1 degrees Celsius. If you want to compare it, it's around 16 times more than the annual climate expenditures by governments and businesses worldwide last year. But many models analyzed by IPCC suggest that carbon removal is the only way forward to limit warming to 2 degrees by 2100. Yes, even with a high capital issue with carbon removal technologies, it seems to be the only way, and the reason is extremely critical that I hinted at the beginning of this video, and I'll share with you in a minute. And therefore, simply reducing emissions won't help. Global CO2 emissions from fossil fuels hit a new high of 37 gigatons last year. But this doesn't mean that the deployment of clean technologies is slowing down. In fact, it's attracting the bulk of new energy investments around the world. And also, the International Energy Agency projects that annual emissions from fossil fuels are set to peak in the coming years and drop to 35 gigatons by 2030. But the path to increasing the renewable energy share in order to limit the warming to 1.5 degrees is not going to be easy at all. It needs to increase by about 7-folds, producing more than 4 times as much electricity in 2050 as coal, natural gas, and oil generate today. And even this starts to look easy when cleaning up of hard-to-abate sectors like cement and steel are involved. There are still no ready-at-hand solutions to replace them for buildings, offices, homes, and machinery. The same concrete and steel contribute to 13.5% of global emissions. Now coming back to the most important question, that is why carbon removal is the only way forward to limit this warming. The same reason makes it even more important not to plan for carbon removal in the latter half of the century, as suggested by few climate models. A group of scientists from the University of Miami have made an alarming discovery. They have found that as more carbon dioxide is released into the atmosphere, it becomes increasingly more potent. Until now, this wasn't known. To understand this, it's important to know how Earth receives and loses heat. A portion of solar radiation from the sun gets absorbed by the Earth and re-emitted as infrared radiation. But the greenhouse gases in the troposphere, that is the lowermost part of the atmosphere, absorb these radiations and do not allow them to escape. Only a small portion is absorbed into the stratosphere from where it is radiated back into space. But as more and more CO2 is added, the absorption of these infrared radiations gets stronger. Most of the outgoing radiation get blocked here, with a very small portion reaching the lower stratosphere region that keeps emitting heat radiations into space. Now, since the energy received from below by absorption keeps reducing, there is a net energy loss from the stratosphere resulting in its cooling. Point to note here is that the amount of heat trapped in the atmosphere from this proportionate increase in CO2 has long been thought of as constant, but the new findings show it's not. So any future increases in CO2 will provide a more potent warming effect on climate than an equivalent increase in the past. This is even confirmed by a UCLA-led study. But this is not the only danger. There's another one lurking near to the Arctic that can accelerate global warming at an unimaginable scale. The Arctic continues to warm at a rate that is currently twice as fast as the global average. This warming is causing permafrost to thaw or melt. As per Wikipedia, permafrost is soil or underwater sediment which continuously remains below 0 degrees Celsius for 2 years or more, with the oldest one being continuously frozen for around 700,000 years. Organic carbon contained in soils of the permafrost region represents a climate-sensitive carbon reservoir. As it heats up, the increased microbial decomposition releases stored organic carbon into the atmosphere as greenhouse gases. Just to give you an idea, permafrost covers a quarter of the northern hemisphere's land and stores around 1.5 trillion metric tons of organic carbon. Now combine this with the exponentially increasing greenhouse effect of CO2 from every bit of its new addition into the atmosphere that I talked about a minute back. The combined effect of these two events is dangerous because both of them are interdependent and fueling each other. Therefore, this deadly combination could have a snowball effect that might slip out of the hands of humanity if left unattended. All this simply points to removing carbon from the atmosphere at scale and not just preventing it through renewable energy. Of course, rapid replacement of fossil fuel with the renewable sources cannot in any case be ignored. What do you think needs to be prioritized so as to limit the warming by 2 degrees by the end of this century? You'd agree that we have not yet understood nature completely, but our job is to continuously hunt for low-cost and scalable solutions that can help us get out of this mess. Can colonizing Mars or the Moon help? I think even if we eventually achieve this feat in the future, we'll end up creating the same mess there as we have done here on Earth. And even setting up a base on the Moon is a huge engineering challenge in itself. Check out my video to get the real insights as to why it is so. Subscribe to the channel, and thanks for watching.